Like I said, I'm JJ Asghar. I hear that picture makes me look pretty attractive. I don't know if that's true or not. There's a giggle. I heard a giggle. That's all I'm looking for. There we go. Thank you. So the first statement is why is Chef building building another product? Well, we still love configuration management. There are multiple configuration management tools that do exactly what your infrastructure needs to do to build up the control plane of your infrastructure, so of your application stack. We all use all these different ones. Obviously, I'm partial to the Chef. Over time, as you start using configuration management, you'll start wanting to do more coding. You'll start wanting to start building your whole stack in code. And there's a statement that goes around internally at Chef where Chef is awesome for 80% of your needs and your business. But that last 20% is really hard. That's the application stack. Automating your WebSphere installation, automating your Java app, automating your Rails app. That's hard, like it really is. I mean, that's the reason why things like Capistrano exist. So I'm supposed to say some more things here, but as I said, we're going through this quick. So as it says, things could be better. Centralization allows for command and control. As your infrastructure builds, you want to have a centralized system of truth, or name of truth, what's the term? I don't know. Source of truth, thank you. Once again, interaction, yay. And I will stumble on words like that constantly. So over time, that'll happen. Immutable infrastructure is important, especially nowadays in the microservices world. But it's still, how many people have seen a Docker container that started off as a Nginx instance that your boss is like, hey, I need a logger now. Hey, I need SSH. You know, I'm hearing a giggle. I know somebody's seen that before. All of a sudden, you're basically using lightweight VMs. And also, how many people do from Ubuntu at the very top of their Docker file? I know most of you probably do. Maybe you use Alpine. I'll give you points for that, but most of you probably do from Ubuntu. Orchestration is still hard. There's still a single source of truth that has to control and tell people to do certain things. But orchestration it goes back and forth between that instance, and the people to the side of them don't understand it. That's where choreography comes into play. Where choreography is important for specifically Habitat, which we actually have a system that our different instances of our supervisors actually know about each other and can talk. And I'll talk about that in a little bit more. Nobody likes releasing applications. It's hard. Everybody knows that. Tool chains, you'll see me bring up Emacs here in a minute. You know I love my tools. So this is actually a great little presentation of the typical workflow of rolling something out in an ideal world. So let's say, for instance, we need to do some database maintenance. Wouldn't it be awesome if our database talked to our application stack that was like, hey, I need to go to maintenance. And the application stack said, hey, to Nginx, hey, I need to go to maintenance. Start sending all our traffic to, we're in maintenance phase. And then, when we're done, wouldn't it be awesome if the supervisor, or the database in this case, told it back and hey, everything's back to neat, right? You gotta admit, that's pretty cool. It'd be awesome to be able to have that control and, I don't know, control. So the tool chain, the most important portion of this little slide right here is the simplified tool chain. Habitat is written completely in Bash. So for the gentleman over there looking for more Windows usage, well, I guess you can run Bash on Windows now, but you might actually enjoy this. And we're actually getting Habitat supported for Windows very soon too. So we have a PowerShell story with Habitat. Yes, no, you're right. It runs that because it's the .NET story. My bad. And the most important thing right there at the bottom, it's not a replacement for Docker. How many people tell you that it is? That was just because they don't fully understand Habitat. Configuration management isn't dead, mainly because you still need to build up your infrastructure to run your application. Habitat is designed, there's a little line there between application automation and infrastructure automation. Chef is awesome at infrastructure automation. Awesome for setting up your machines, your VMs, your bare metal, whatever you need to do. Your compliance, if you're in a bank and want to make sure that you're compliant to the different tests, you still need something to control that. Habitat blurs that line a little bit, but does application automation. Once again, Habitat is not a replacement for Docker. So these are the main portions of Habitat, which in a moment here, when I start hacking, I'll take my jacket off so I can breathe because it's kind of warm in here. The studio, which is the safe environment that you build all your Habitat packages in. The plans that are actually what you tell to do the thing. The depot, which is where it stores it. So think of like a Docker registry. And then the supervisor, who's our unsung hero of Habitat. And good old Timberman, Habitat artifacts have a heart extension because we love you. Yes. Really? No smile, Jason? Come on now. There we go. I used to work with Jason, so I can pick on him when I want to. So here's the Habitat workflow. There's a lot of words on this, but what I'm going to do in this hacking session with y'all is we're going to build out a artifact. We're going to do the plan in the artifact, and I'm going to ship it out as a Docker container because I'm lazy. And then we can actually push it up to a Docker registry and see. And if you want to, you can actually pull it down later. And if we actually do succeed with it, I'll post the code to GitHub, and you'll be more than welcome to hack on it. Okay. The supervisors, this is a pretty busy slide, but the most important part is the ring right there. Is my mouse on? Yes, awesome. The most important part is the ring where the supervisors can talk to one another. It uses the swim protocol, so you can actually inject configuration things at runtime to be able to, for instance, as the database database to Java to Nginx slide showed, be like, hey, I need to change the schema on my database. You can actually inject that runtime into a supervisor, and the supervisor can intelligently turn off certain things or turn on certain things, waiting for specific statuses to come back to be able to turn things back on. The supervisor has a built-in monitoring solution off of curl, or not off of curl, but it's just a port that you can get against. And so you can actually write intelligent monitoring into your application too. There's multiple styles of control for the ring. The 9 out of 10 times we choose leader follower because you're probably going to have an application that has a single thing that wants some follower nodes off the back, or standalone, which is the easy story. As you can see, the RESTful API down here at the bottom, which is small, you got config, status, the gossip ring. You can actually check into the gossip ring by doing a curl against that REST API. So this is just a way to the process of pushing things out to to verify. So everything is GPG encoded. So when you actually build out your artifacts, your heart files, you know for a fact. So the promise of Docker back when it first started was that you could put out a Docker file, get a SHA, and say that this artifact is exactly what will run exactly the same thing at the same place, right? Well, over time, Docker has done a lot more and no longer has that SHA you don't have confidence in, right? Because you now have to run a Docker infrastructure with that SHA to run that container. The beauty of Habitat is that because we can export out to multiple different formats, not only containers, tarballs, AMIs, soon to be QCal2s, and also VMDKs. Those are in the pipeline. So you can actually dump out a heart file into a VMDK and inject it into your VMware infrastructure, which I was hoping to see a light bulb go off in somebody's head, but I guess it didn't happen. That is unbelievably powerful because that means when your developer is working on and packages something up as a heart, they can say that this is the heart that I was doing in development. I can shove it into QA now, and they can dump it out to an AMI, put it up inside of AWS and test it in a real QA environment, and they have a guarantee that it's the exact same bits. That's pretty sexy. It's a lot more words. And then demo. Okay, so let's have some fun. Has anyone thought of an app?
Chef server.
I hate you so much.
Nginx.
Yeah, well, sure.
You know what? Actually, let's make it harder. How about Redis? Because it's persistent.
Really? Postgres? Okay. Let's try to, like, you build everything from source. So Postgres might actually be an interesting story. But Sharif, you had a question?
Yeah, so I'm the dumbest guy in the room. So just so I understand, right, this will allow me to roll up my applications and tell my, I'll be able to tell my global load balancers, pull these machines out of a pool until they've been updated, and then I can run post-validation tests against that from a QA standpoint before I put them back into the pool.
Yep.
Is that the value prop for it?
That is one of them. So it's a holistic story, which is the cool part. It's not just like when we used to be doing our thing back in the day where we'd have to pull the thing out of the load balancer, run Puppet on there 4 times to make sure that the shit actually worked. This story is completely different in the sense that we actually have something, if you will, running Puppet on there at the time to make sure that it's in a state we want it to, and then we can intelligently put it back in over time. So if something breaks, right, it can actually be out of the pool already, and it's broken in a way that doesn't hurt our application stack.
Because he knows I am, in fact, the dumbest guy. And he has to dumb down. All right.
Sure. Any other questions, statements? I like the idea of Postgres. I was actually going to do Jenkins, maybe because I cheated, but I was going to do, because I'm actually really proud of the Jenkins story. But no, yes?
Let's do Jenkins.
Yay, there we go. Okay. Actually, anyway, can everyone see that? That's probably pretty small. So we have
We'd ask you a question, so I'll get
that good? Everyone can see that? Am I still on the mic? Yes? Okay, good. All right, so inside of, as with all new bootstrapped, okay, so actually, let's take a step back real quick. One of the stories that you probably heard through the different avenues, which was that Habitat can be a replacement for Docker, hence it's not a replacement for Docker, is that we buried a lead on something, which is that Habitat is a new packaging format. As an engineer, the ability to package everything up as that heart is unbelievably powerful, as I was mentioning a moment ago. But I want to make sure that is very clear, that it is a packaging format that has a built-in supervisor that allows you to really adopt a microservices mentality, right? So how many people actually use microservices? Who actually knows what a microservice is? There we go. Okay, cool. So how many people have actually tried to build, that isn't actually running an app, microservice, trying to make their app in a microservice architecture? Okay, we got a couple tried. If you're willing to answer, are you successful or failure? Can you elaborate on that? Okay, all right, that works. How about you, sir?
We are testing it.
Okay,
We had success in a non-prod environment.
okay,
But after some testing, we will move it in prod.
okay, okay. So to paraphrase, it's challenging
It is.
to convert from a monolithic style to a microservices architecture. That's challenging. That's accurate to say? Okay, cool. So I genuinely believe Habitat makes that step a little bit easier, where you can package things up from Jenkins to a much more advanced flow of things. So in one of my stumbling blocks when I was first learning Habitat was I thought that I had to build a package that, for the Jenkins story specifically, I had to put Nginx, Jenkins, and Tomcat all in one heart. Who thinks that's a good idea? Just from everything you know about Habitat. Okay, maybe I'm just dumb then, because it turns out that's not what you want to do. You want to leverage the microservices mentality where you can have a Nginx heart, you can have a Tomcat heart, and you can have the Jenkins heart, and they all just talk through the network through a certain exposed port. That is the crux of making Habitat successful. When you realize you can break your app up into little bits and pieces that can talk over a port, it becomes unbelievably powerful. So what I've done here is Habitat Jenkins and plan. So this right here, this is a typical Habitat plan. And as you can see, I was lazy. And also as a proof of concept, you'll notice that right there. I actually pulled down the WAR file directly from Jenkins, and my story is a lot of people build Habitat packages by building things from source. But I know for a fact a lot of people they have WAR files because they have their own build process or whatever, and they want to just be able to run their package. They don't need to build it from source because they need to just push it through this interpreter to do the thing. This is what this challenge was for me, is I wanted to pull down a public WAR file. First of all, it's Java. I know little to nothing about Java. I failed that class a few times in college. And I wanted to put it inside of a heart. So what I did here is I pulled the Jenkins story. And as you can see, I make sure that it's the correct one that I want. I have running dependencies here, which includes this JRE8. I could have picked anyone. JRE8 was because I was lazy. And then when you start up Jenkins, starts on port 8080. Cool? Well, somebody take a guess at what you think this does. Yes, awesome. 80 miles an hour, that doesn't work. So yes, I overrode the typical download story because we have multiple steps inside of a Habitat plan that you can read in documentation. But normally, it tries to pull down a tarball or a GZ or even a clones off of a Git repo or goes to FTP to pull down a compressed file. This do download tells wget, hey, go download it, take it, put it in the package file named source, to put it in the cache, and then dump it out or pull it from the package source. And then I'm like, hey, don't worry about verifying it because I know you already do that. I don't need to unpack it because it's a WAR file. You don't really want to unpack a WAR file. And then this right here is literally the install, where it copies from that same location and then copies it into another name called jenkins.war. So for what you know of Jenkins, how do you start a Jenkins server with a WAR?
Copy the WAR file.
Yeah, exactly. It's literally hooks. I can't type because everyone's looking at me. Hooks, run. That looks pretty straightforward, doesn't it? This whole script, the most important part, well, it's actually the LD path, but that's a different conversation, is this right here. Hey, run that WAR file. Pretty cool, huh? Like, imagine writing a Puppet manifest or writing a chef recipe to install this, right, for a configuration. Now, I can actually run this inside the studio, dump out a heart file, and it's repeatable and consistent, and that's pulling it out from the internet to do it. I'm going to challenge myself with this. What? Yes, please. Yeah, he asked, well, how is this different than using Packer, Docker, and Chef Solo? Is that accurate? Okay, so yeah, that's true. The built-in supervisor. Also, being that the ability to export out a heart file to multiple different styles of systems, you don't only just have what Packer tells you can do and what the container says you can do, right? So we give more flexibility. We give abstraction on the packaging format that allows you to build out everything you just need for that. So you're not doing your from Ubuntu inside of inside of your Docker file anymore. You're going to actually spin up exactly what you need, which in this case is right here. These are the only dependencies I need. I don't even need a shell, right? All I need is JRE8, GCC libs, and glibc to make sure that that is all I need to run Java pulling down this thing, as you'll see here in a moment. So it's a really, truly stripped down artifact of everything you need to run just that thing. Going back to the microservices story a moment ago, where when you start thinking everything in small bits and chunks, then all of a sudden, why do I need cups in my container? This seems dumb, right? How many times have you seen cups inside of your container? I know you have, right? Yeah, there we go, I got a giggle. So it's true, this actually strips that down.
Wait, JJ?
Yes, sir.
What you're saying is true, then in a Docker container, I should be able to build it from, sorry, if what you're saying is true, I think, as I understand you, then I should be able to build a Docker container from scratch around the Habitat heart file or the output of that.
Yeah, exactly, and that's what I'm just about to do. I'm going to strip it down to the bare minimum using the exporter for Heart to give me a Docker container of the least amount of things I need. Yeah. Yes, sir.
Is the heart file similar to Docker file?
No.
Fact?
No. So the best analogy, or the best analogy, I guess is the right word, is the plan is as close as you can get to the Docker file. But you'll see this here in a moment when I run it, because you'll actually see the output. So let me.
By the way, what's a Docker image analogy in Habitat?
So a Docker image would be what we're about to export. So it's the export. Yeah, go ahead, Thomas.
So Habitat's more the thing you use to build the Docker image. It doesn't. That's where it kind of sits in that story, as opposed to the Docker image itself. So you could have Habitat build that, or you could have it deploy to bare metal, or a bunch of other things that Chef's working on.
So then is it true, Thomas, that what JJ showed us, or JJ, that what happened here is that you've essentially obviated the need for a Docker file and all the Docker layering?
Exactly.
So you're really going to get a Docker container with really no need for a Docker file and a single layer.
Correct.
Okay.
And then that same, and to reiterate, you'll be able to take that same Heart file and export it out to an AMI, bare metal, whatever, Mesos, whatever the hell the other ones are called, and be able to do that. It's unbelievably powerful. Because right now, if you spin up a Docker file, you're stuck in the Docker ecosystem, right? So, all right, so here we go. We are actually building the Heart as we speak. Here we go. That's what it is right there. It's compiling it down, or it's compressing it down. Compiling, Jesus. So.
What language is being used in creating the heart file? Is it batch?
So the actual. Yeah, the question was is what language is everything being written in? The actual. It's a nice little fun thing. It's fine. It's a fun little ring. The actual plan is written in. Everything you interact with Habitat is written in Bash. Everything you do is Bash to do that. But the actual application is written in Rust. Okay, so there we go. And when you see this, you know you're winning. Right? Nothing? Come on. Anybody? All right. So now that I have that, I can go ahead. And as you can see, I have the checksums against here. It is GPG encode or signed via my origin down here. So if I wanted to, I can now ship this to the excuse me, to the depot and be able to say that you can pull down this exact one. So I can change something around, but you'll get the point here in a second. So I can now do hab export or pkg export docker JJ Asghar Jenkins war. So now this pulls down the Dockerize plugin for Habitat. And then it actually pulls down Docker, because how is she going to write it, right? And then I start thinking about it. as you see, it's installing the Linux headers, the JRE, installing Hab inside of what's needed done it, actually pulls Hab soup inside of it, which is the supervisor. And here we go, talking to the daemon. No whammies, no whammies, no whammies. As you can see, here we go. Here is the equivalent of the Docker file, step 1 from scratch. Actually creates a path to everything you absolutely need, nothing more, nothing less. Then dumps everything into root fs. Come on, don't make me a liar out of me. Maybe. There we go. We're getting somewhere. And there we go. Okay, so we've successfully built it. So you're like, JJ, that's cool. That's cool. No, it's not. Okay, so let us go over here and go to Docker. Nope. Actually, I'm actually trying to do PW utils because it turns out we don't have that done. So I will leave that there, but I will come over here and I will be like Docker images grep Jenkins. So as you can see, I've done this a few times, but the most important one, 32 seconds ago. So I've already injected it into my local registry. Cool, right? So I should be able to go to Docker dash, what is it, RTI? No, what the hell is it? I'm going to cheat and look at my notes. K8. So then I should be able to do that, Docker, then do port 80, then do JJ Asghar, Jenkins. Oh, shit, thank you. Jenkins, war. And there we go. This is actually in local mode running the Java instance. As you can see, this is the Hab supervisor going on. There's a supervisor on that IP, so now I can actually connect to that supervisor if I need to. I can update the config if I need to in real time. And as you can see, there's all this stuff. Here is the password. There we go. Jenkins is fully up and running. So let's see if I'm a liar. I never used Safari, so let's do that this way. Localhost port 8080. Boom. Pretty cool, huh? No? Yes? Nothing? I am really genuinely proud of this. Then I can log in and I can do the things.
So basically what you did is using Habitat, you created a Docker file, a Docker image. Mm-hmm. And from Docker image, you spun up a Docker container.
So as a demo, yes. But the beauty of it is because what I'm trying to get across is because I have this specific, where'd it go? This guy, right? This guy right here, that artifact right there, I can ship that now into an AMI, a tarball, a Docker file, soon to be a VMDK, soon to be a QCOW2, soon to be XYZ, because the exporting is extremely easy. We just need to make them all happen. And I can export it and create that same thing. I only use Docker because it was just it's a way for me to show it quickly, right? But there's that heart file I can export out eventually to a VMDK, a QCOW2, an AMI, and get the exact same code in all those same places.
Like for example, if I want to run Docker commands, I need to have a Docker engine, which will install Docker daemon. Similarly, if I want to write the chef recipes, I need to have chef DK on my desktop. My question is, in order to write .heart files, what do I need to install on my local machine?
Oh, so we have a binary called the Hab binary, HAB. You can go to habitat.sh, and you can download it for Linux and Mac OS right now. Windows is soon to be released, where you can actually just type Hab Studio Enter, and it will pull down everything it needs to be able to get into the environment that it has a clean studio to enter and do the thing.
Right.
Yes, sir.
How big is your Docker container?
That's a great question.
Can you
Well,
repeat the question?
how big is the Docker container that we just created? So if I'm correct on this, and this is probably going to become a liar here, the actual WAR file is about 65 megs downloaded. And because of the stripped down nature, it shouldn't be much bigger than 65 megs. 65 megs. I see myself in the background. I haven't actually been watching myself in the back. Normally I do that, but I'm just 65. Okay, let's find out.
I love you too, JJ.
All right, so, because everyone's watching me, I can't type anymore. Why am I bringing up my help? Go away. Okay. So I don't actually genuinely know this off the top of my head. Do you know the Docker command to see how big images are? Is it Docker PS? There's no way to like do a Docker like show
What about Docker images?
Docker images. Grep. JJ Asghar. Jenkins. War. Oh, well, that's not as awesome as I thought it was going to be. Good point. That is a good point. So yeah, it has all the Java dependencies, and so okay, it's not. I genuinely don't know the answer to that. I would be very interested, and if you do find that out, I'd love to find it out. I genuinely don't know. But that was kind of the story what I was going with the Jenkins pull down the WAR file, push it through Java, right? Which was, my goal was to show that you don't need source code. You can still do a binary. And yes, the binary is 65 megs, and the Docker image is now 421. Man, I screwed something up. So that's unfortunate. I mean, in a microservices way, but granted, when you get, how big is a heart file? That's a good question. So let's see here. And now this is recorded, so everyone's going to see me screwing up like this, and we're going to have a nice post-mortem on this one. I know we are. Not even a giggle? Nothing? Okay. Where the hell did it go? Oh, here we go. So this was the actual heart file was only 65 megs. So that's still consistent with what we're trying to do. But I guess to Thomas's point, because we inject Java inside of there and we inject the CLibs, GCLibs, and GCC headers, what is it? The core GCC libs and glibc, I mean, that kind of makes sense, right? Because that's quite a bit of C that's got to be in there to be able to run. No? Any other Linux hackers here to confirm or deny this? Where's my Nix guys? Someone's got to use Nix. Gentoo? Anything? Arch? No? Okay.
I had a question. How do, like when you're exporting to Docker image, all the commands that you have in Dockerfile, for entry point and everything else, how does that fit in here? Where does that get set? How do you control? How do you manage the creation of your image, the creation of your image?
So yeah, like for instance, entry point is what the supervisor runs. So the supervisor would do the run hook command, which is the this run right here. So this would be the equivalent of your run.sh that your Docker container would run. This is what the supervisor actually takes and runs. There's also an init hook that allows you to do bootstrapping init when you first run it for the first time. But if it dies, the run command is what runs after every single time. So you do an init, a run, and then if it dies, it does the run command again. If you expose certain ports, that's what, for instance, package expose here does. We have a one-to-one relationship with all the major points of the Docker file to do the things. I would just double check the docs, to be honest with you, but those are the ones off the top of my head.
And so that's the abstraction on top of
Yes.
you know all these things. You've kind of bubbled them up to a higher level, regardless of the you know the target output.
Exactly.
I get it.
You're going to say something, Thomas? No? Okay. What else can I answer? Yes.
There are a way to define the connection. It's multiple elements in application.
Sorry, say it one more time.
For example, here it's only a Jenkins server.
Yes.
If you have a 3 tiers application,
Yes.
how do you define the connection each element or?
So this is kind of where I was going with that, the allusion to the microservices idea, where say if you have a database, an application layer, and a web server, right? What you would do is you would create 3 heart files for those application tiers and have their own gossip ring for each one. So all your web servers know about each other, all your application servers know about each other, all your database servers know about each other, right? And then you can inject the different needs at that time and then be able to actually talk to one another too through the supervisors. I would strongly suggest right now, the best practice is only to have hearts create application stacks for specific uses, back to the microservices mentality. Did I answer your question?
Yes.
Okay.
So what I don't understand, I think, is the supervisor, how it works, or what is it? For example, in Docker, here is running the supervisor.
Okay, so the supervisor is, it allows to, it has state awareness, it knows what's going on, you can query it for information. So the story goes is as you build up your Docker container, eventually you'll either inject something like Runit or Blue Pill or any of the other supervisors inside of your container, because you're not going to only just run one process in there, you're going to need a logger, you're going to need SSH because your boss hates you, you're going to need something else inside of there because over time your Docker file gets bigger and bigger and bigger, and you have a supervisor making sure everything's up and running. What we're doing is we're giving you a supervisor that its job is only supposed to do one thing and one thing extremely well, but it is state aware around other machines in the ring. So you can inject things on runtime or tell things intelligently to come down one at a time because you have to restart everything without causing whole application stacks going down. Does that make sense?
Yeah. Okay.
There's more to it, but that is without actually getting your hands dirty and playing with it and seeing the power that is the supervisor, it's really hard to say in words. That's a cop-out answer, I know, but you really do just need to play with it.
Okay. Thank you.
Sure. What else can I answer? What can you, Jason? Well, there we go. I appreciate that, Jason. Jason just pointed out that the JRE 8 is actually 150 megs. So that actually brings us even closer to what we were thinking. So there we go. Awesome. All right, Job, what can I answer for you? Yeah, man. I know you got questions.
I mostly just want to know what your like your process of getting ready today was, because you look fantastic.
I'm not wearing my coat though. I need to be putting my coat on, but it's just really hot. No, actually, to actually answer that question, I was really proud of myself when we got this working with my teammates. This actually is a story that we don't tell very well, which is a practical use case. And I'm not supposed to say this, and it's now recorded, so I'm going to say it anyway. I'm actually planning on. I've been able to get Habitat working inside of Kubernetes and be able to have the supervisor have intelligence about your Kubernetes infrastructure. So you can actually have deployments scaling out horizontally and vertically using pulling from the supervisor. So imagine a build farm of habitatized, I can't say that, Jenkins masters and Jenkins slaves, where you could spin up your build farm inside of Kubernetes horizontally, run all your build jobs, and then tear everything down in seconds. If you're not excited about that, I don't know what I can. I think I'm talking to the wrong audience. There we go. I got some guy laughing over there saying, he doesn't believe it. No, I do. I'm really proud of this. I'm not ready to show it to prime time yet, but I'm getting really, really close. So, have your own Travis. That's pretty cool, right? No? Yeah, there we go. So I was hoping to show it off today, but not quite there yet. Oh, and in theory, you could run it in Karina if you wanted to, just to make it back to Rackspace. Because, yes, Sharfwood.
Hey, JJ, what's my migration strategy here? If I want to start trying to implement this in my environment, do you have a, first pass at this? What should I be thinking about from a development DevOps standpoint?
That's a great question. So the best way to start thinking about playing with it is finding a small web app that you can probably start thinking about in microservices and that mentality. The challenge isn't so much the technology; it's how you've built your app in the past and breaking it up to the flexibility and the flexibility and agility of microservices compared to your monolithic Java app, which is kind of where I was going with this story, where I have a monolithic Java app, and now I've been able to wrap it up inside of Habitat to at least show you that you can leverage the supervisor to do the things, but there's no reason why you couldn't break up another smaller like Ruby app or Rails app or Python app and be able to do it that way. And my battery's dying.
Curious about the thing you said just before.
Sure.
I was in a place where we were trying to elastically scale Jenkins, and we were having a lot of problems with connecting the slaves and the master just. So what you're talking about there, are you talking about spinning up an instance where you spin up the master and the slaves dynamically together? Or are you talking about spinning up the slaves dynamically, connecting to the same master using some mojo you got going here?
Second answer. And I believe I have almost it working. I'm running into, believe it or not, SSH issues, but there's no reason why that I cannot dynamically use the supervisor who knows about the state of all the machines, that has a configuration file on the Jenkins master, and when I say kubectl scale 1,000, right, it can spin up 1,000 of the what would be considered the Jenkins slaves nodes in a deployment. They all get private IPs. They all know about each other, and they tell the master because they're all part of the same ring. And the master's like, hey, I just got a bunch of new machines in here. And it tells that and updates the configuration file for the slaves inside of there and be able to do this stuff. And then all of a sudden, all these new build nodes appear out of nowhere, and I can basically cron it, which would be amazing, right? So, and I'm as I said, I'm really, really close to this, but I'm just not quite there yet. Sure.
Quick question on the artifacts that you had shown. Other than the heart file, what other artifacts do you really save?
It's just a heart file. It's just
The heart file.
Yeah,
So, so the heart file will have the plan within it?
Yes.
Okay.
Well, no, it doesn't actually have the plan inside of it. The plan is outside of it. The heart file comes from the plan. If that makes sense. So the artifact is just the running instance of the supervisor and whatever you've declared in your plan.
So if you wanted to have a workflow for developers to save this off into your version control system, what are the files and that you really want to save?
Sure. So what I've done is Habitat Jenkins. So here is what I just showed you guys. And I have the plan.sh here, and I even have the commands if you guys want to play with them. And this is everything you need to produce that heart file, and then I can ship that heart file wherever I need to go. See?
Thank you.
A plan to run Jenkins and Habitat via a WAR file. That's all it does, but it's actually really cool. Nothing? Nothing? No, Thomas.
So what's in that default.toml file?
That's a good question. So inside of the config file, where you can have configuration options. Now, back to the slave statement earlier, I haven't pushed up the slave configuration yet because I'm still working on it. But as you can see here, there are mustache configurations where I can now flip things on and off. So the TOML file or the environmental variables of being able to start up a supervisor or a Habitat instance, you can inject either environmental variables or a TOML file to do things. For instance, right here where I have this disable signup, I created a specific line in it to be able to flip on and off the signup if I wanted to. Or for instance, down here, the slave port. So if you go into the TOML file, by default, these are what the things are going to be, which is slave port of -1 and disable equals true. So I could inject that during runtime or during start or whatever I need to. And this goes to that level of the injecting runtime configurations to the supervisor inside the ring. So if I had multiple ones of these machines and I was like, all of a sudden we're going to change all our ports to 9090, I could inject it into the ring saying, hey, everyone needs to change their slave port to 9090, and they'll intelligently restart with the correct command. Once again, this isn't 100% done yet, but it is that is the typical workflow. Did I answer the question? Yes, awesome. Do I sound like I know what I'm talking about? There we go, awesome, even better.